Okay, so here's the similar triangle question. So if you imagine if I've got a square and then I enlarge that square, then these two are similar shapes. So if my first shape has a side length of 1 and I enlarge it so that it has a side length of 3, that means that my scale factor is equal to 3. Okay, and that means that the area of this one is 1 centimetre squared, and this one's going to be 9 centimetres squared. So scale factor is for sides, but the area is equal to the scale factor squared. Okay, and then if I think about these as similar shapes, then the ratio is 1 to 3 for side length, but for area, it's 1 to 9. Okay, so now let's look at our triangle. So for my triangle, I've got two similar triangles. I've got the big triangle, which is ACE, and then I've got the smaller triangle inside, which is BCD. Okay, now, quite rightly, we've labelled it here because it said the ratio of the areas. Right, so triangle BCD is 4x, and ACE, and the quadrilateral at the bottom, which is the extra bit, is 5x. Okay, so now that means that this big triangle, which incorporates both of them, must be 9x. Okay, so that means now that the ratio for area for our triangles is 9 for the big one to 4 for the small one. So again, remember, this is our scale factor squared. So that means that our sides are going to be 3 to 2. So that means that the big one, if this is 3, this side will be 2. And again, remember that these two are connected together to make the big one. So if this is 2, this must be 1. Because 1 plus 2 makes 3. Okay. Now the question says that AB, which is this side, is equal to y. So that's that. And we want BC, which we said has to be 2. So that means that must be 2y. So the length of BC is 2